So I wanted to introduce Mark Maybee. Mark has never worked on OpenZFS. So why did I invite him to give the keynote for our conference? So Mark has been with us since the very beginning. He started working on ZFS 16 years ago when it was like, I think he was the third or fourth person to work on ZFS. He's been working on it ever since, at Sun for 9 or 10 years, and now at Oracle for 7 years. He's worked on ZFS when it was just a general purpose file system in Solaris. I should preface this by saying he's worked on ZFS in a lot of different contexts. So when it was a general purpose file system in Solaris, he worked on the ZFS Storage appliance, which has generated over $1 billion of revenue for Oracle. And he's now working on the Oracle Cloud Storage team, which is operating ZFS at a massive scale. So I invited Mark to come speak to us about both ZFS's past, how did we get here, and what he sees for the future. What does ZFS need to continue to be a critical piece of storage for the next decade? What's ZFS's place in the software ecosystem? So with that, welcome, Mark. Slides up here. And then you should, left and right should go.
All right. Thank you, Matt. So yes, as Matt said, I have not been engaged directly with the OpenZFS community before. I have certainly kept in touch with a variety of folks who are engaged with the OpenZFS community, but my history recently certainly has been more in the other branch of ZFS, I'll call it. So, although on your schedule it says this is talk of ZFS past and future, I broadened that to say it's actually ZFS past, present, and future. This is really going to focus on what has happened to ZFS that you may not be aware of in the Oracle branch, if you will. Let's start with a bit of the past. I'll start from the very beginning just to get a place mark. Yes, as Matt said, in the beginning, it was Jeff who sort of had the idea of pooled storage, and Matt who did the first transactional DMU engine behind ZFS. And it was Mark Schellenbaum and I who were engaged very quickly after that to develop the file system that sits on top of that DMU. But I want to sort of skip ahead quickly from there, because you've heard already from Jeff, I know, and from Mark Schellenbaum in the past, and I'm sure from Matt, reminiscing about those early days of ZFS. And they were amazing days, but what I think you may not have heard about before is what happened in the history of ZFS after it became a closed source within Oracle. So Sun Microsystem was purchased by Oracle in 2010. At that point, ZFS branched, an OpenZFS community emerged after that, and within Oracle, though, ZFS continued. Right? It wasn't the end of ZFS from that perspective. And in fact, that's when I became sort of the primary architect of ZFS development within Oracle itself. So this is that story of what happened to ZFS there. And the story starts with Fish. I know there's some people here from FishWorks. Before Sun Microsystems was purchased by Oracle, a new storage product was developed within Sun Microsystems and by a group of very bright engineers who wanted to take the technology that was embedded in Solaris and build a premier storage appliance around that technology. It was designed around the ZFS file system as the primary service. It leveraged the capability of Solaris, both from its stability perspective as well as from its observability perspective. dtrace was a key component of that product. When at the point at which Oracle purchased Sun, that product had a relatively small footprint in the market. It was a new product. and it hadn't been on the market very long. It was really targeted in those early days towards sort of a mid-tier, medium-sized business. That was where we were selling the product in at that point. And when Larry bought Sun, one of the first things he announced was that I'm going to rebrand this thing, which was in those days called the 7000 series storage appliance, to be called the ZFS storage appliance. He wanted to highlight the fact that ZFS was the technology in it. He knew that his IP around ZFS was key to that product, and he knew that brand would help sell that product. But what had he bitten off? At that time, NetApp was a dominant storage within Oracle. The Austin data center, which is their premier data center in those days, was a showpiece for NetApp. This slide comes out of a sales deck from NetApp in that era, around 2008, I think. So they had, in their data center in Austin, they had over 12 petabytes of storage behind NetApp, serving over 20,000 servers. All right, so and mission-critical software in that environment. So Larry was asking us to go in there and replace that data center and all the hardware in it, or at least all the storage hardware, with ZFS Storage appliance. So we roll out a 5-year plan. And actually, things looked promising in the sense that the performance characteristics of that storage appliance were pretty impressive, and they were actually be able to replace NetApp appliances at a ratio about 3 to 1. 3 NetApp appliances for 1 ZFS storage appliance. And this is across their entire fleet of infrastructure. So this was replacing not only the product development storage, which is actually where we first got kind of rolled in, because that was, management was okay with some instability there. That was fine. But eventually we went into their, what they call the global infrastructure, where they did payroll, et cetera. And that was towards the end. And in between, we even rolled out into the customer infrastructure, where Oracle was actually selling services that required storage to customers directly. Now, this was all happening with a new product, relatively new product. ZFS, the SA had only been on the market for a few years at this time. So, for us, this was really a trial by fire. We were going in there and we were trying to force into an ops organization that was intimately familiar with NetApp a new model of storage. I'm sure many of you who are familiar with talking to customers who are familiar with more traditional file storage services and trying to tell them and explain to them how ZFS differs from what they're used to, and that you don't need to do the things you do. When you get a hotspot in ZFS, that's a good thing. It's not a bad thing. And these kinds of conversations were ones we'd have frequently with the ops team within the infrastructure of Oracle. But on top of that, this was a new product, and there were issues. All right, it was being rolled out at a scale it had never seen before. It had never been rolled out at this scale before, and it was growing. It was evolving. It was becoming a solid piece of software and hardware, but it took some time. So in these days, Tiger teams became a frequent occurrence, and by Tiger teams, there are Tiger teams in the storage side. Although we had problems all up and down, from the hardware down through all the software stacks, it was always the storage that was the problem, at least in the minds of the people who were having the problem. And so I was almost always on these so-called Tiger teams. And we were constantly having daily meetings, jumping on problems, trying to deploy fixes to them as quickly as possible. And because this was an Oracle infrastructure, that fix occasionally even required us to go to the top levels of management to get, quote, approval for those fixes. I can remember having phone calls with Edward Screvens, the VP, or not VP, the chief architect of Oracle, explaining to him that, yes, it was okay that we reduce the ARC cache size significantly on these boxes because we were seeing some issues where we were losing storage in the magazine layer, and so we really needed to keep it capped a little bit to give some breathing space, otherwise systems would lock up. And getting his nod of approval and going through and applying a patch that said, all right, limit the ARC to this size now for a while until we get this bug fixed. Overall, these were pretty ugly days. At one point, I don't remember exactly what year it was. It was probably around 2012 or so. The VP in charge of the operations in Oracle called a meeting. She requested a meeting with Larry. And she walked in with a deck that said, was going to explain to Larry why ZFS was failing in her environment and had to be replaced with with NetApp. We had to go back because ZFS was not meeting the need there. And famously, at least within our team, Larry looked at her and said, yeah, there is no plan B. You will go with ZFS. That was cool, but it was also, increased pressure from our perspective. We were continually trying to adapt to the situation and stay on our feet. With this, of course, there was a lot of shift in focus around the ZFS team. To this point, ZFS had always been looked at as primarily the core file system within the Solaris operating system, right? And that's where we spent our focus. We looked at what Solaris needed from us. We looked at what its use cases were in a server environment. And we looked at what features it needed in that environment, and we were constantly developing to that target. Now we were moved from core Solaris, and we are placed into a storage organization directly. Around that time also, we lost some relatively key individuals. Matt departed the team around that point, as well as Jeff and George. So it was an interesting shift. And so we were busily trying to hire up some replacement talent. We managed to fill the gaps with about 3 or 4 people to 1 there to fill that need. And even there, I don't think we really filled the need. We simply patched a leak. But we made progress. And we focused from a development focus more towards a stability focus within the team. So I can remember having a conversation with a director at that point, walking in my office saying, your bug counts are really high, and we really are in a tight place here. Can you shift your team's focus over towards fixing bugs? And I said, yeah, I can do that for you. We can do that. And in fact, if we looked at that point in time, around that point in time, our bug churn rate was very high. We were pulling in roughly 25 bugs a month, new bugs a month were being filed against us, and we had to keep on top of it. And so it really was a, fix a bug sort of mentality for at least a short period of time in this space as they creeped in from their use case. And you can see it varied quite a bit. And this chart shows actually skyrocketing at least at one point. But overall, we did get a handle on it. The ZFS team got a handle on the bug situation. We even managed to reduce our overall bug counts. We were actually at a high of about 400 outstanding bugs in the ZFS software product at the time in 2010 when we started this. And within 2 years, we had managed to lower that to about 200 bugs. And even with an incoming rate of roughly 25 a month, we were maintaining about 200 bugs, of outstanding bugs. And so it was pretty impressive from that perspective. I mean, we kept on top of the bug situation pretty effectively. And we weren't just doing bugs. So we were still doing feature development. Now, as some of the old timers would probably have been a little bit frustrated by the fact that there was a lot of bug fixing going on, and feature development was a little bit on the side, but we'd snuck it in. And we were able to do more and more as time went on. As the product stabilized and things got better, we were definitely doing more and more of that. And performance was also dramatically improved over these years. When Fishworks first introduced, sort of an aside, the ZFS storage appliance, or the 7000 series storage, they had introduced it with this concept of the 16 metrics. I think it was 16. I may have the number wrong. But it was a observation that, there were these industry standard benchmarks out there, but they weren't really representative of storage. And they're kind of being exploited by the storage vendors. And we don't really want to play that game. Instead, we're going to define our own set of metrics, which are more representative of storage and really represent what you need and what you want to see in a storage product. And that made sense. But it fell flat because customers didn't care about our 16 metrics. They cared about the industry standard storage metrics. And as an aside there, I think there was a concern and a worry on our part that we couldn't match industry standard metrics because they were really designed around a storage model which wasn't quite our storage model. But we were actually pleasantly surprised when we eventually decided, okay, let's go get into the game and let's play that game. And I'll get to a slide here in a second that shows that. This shows you our bug count. So this is a graph that actually tracked bug counts between July 2008 through July 2012, and you can see that we had that spike of around 400 outstanding bugs in 2010, and then slowly chipped away at it, and by early 2011 we had basically pulled it down to 200 and kept it there pretty much. I mean, it obviously fluctuates up and down over time. And these are a smattering of some of the new features. I know many of these will probably look familiar to you. I know that some of these have been also implemented in the OpenZFS environment. I think this highlights, though, that this is a different trunk. So things did proceed a little bit differently over here. Some of the directions we took are different. Some features that might look the same are probably significantly different in the way they're implemented within the product. I think some of the more interesting features on this list are the asynchronous dataset deletion. So we moved dataset deletion into the background as an asynchronous process. That was important to us from a product perspective, a storage appliance perspective, because we were going into environments where there was this demand that deletion be instantaneous. So I don't know, all of you who are familiar, and all of you are familiar with ZFS, know that deletion is we actually, in the short period of time you wait, we're actually going through and clearing out all the space maps and freeing up those blocks before we turn back to control back. And that was just too long to wait for these customers, even though we still had to do that work. And so we implemented an async destroy that made them happy, even though the space would come back over time. They didn't care about that. We also did a lot of work, and a lot of the features up here are all around performance. So changes to improve the block allocator, a significant rewrite of the arc to change a number of the elements of its architecture. It certainly has the same functionality as it had before, but it's organized in a fairly significantly different way these days. The improved NUMA locking we discovered in a number of places as we scaled things larger and larger. We were, at this time, scaling, because we were not also, I should point out, not just developing for the appliance, which, by the way, was continually increasing its processor power, but we were also continuing to develop for Spark architecture, and that was pushing us to our limits in a lot of places with its multi-threaded behaviors. So we were having to scale our locking to be able to keep pace with the processor. And what's amazing is we could. I mean, it's amazing to see some of our performance numbers on some of the Spark hardware. It's sad that it isn't deployed more in that environment. And then sequential resilver was added some time ago, and an I/O throttle control, which I think might be interesting to some. It was put in place, again, from a storage appliance perspective to allow us to be able to throttle specific client access to specific data sets. And it's primarily used by our customers in a VM environment where you're deploying VMs to a lot of clients, and you want to avoid the noisy neighbor problem. So you can place throttles across all your VMs, say this is how much bandwidth you're allowed your max out at, so no single client can dominate. All right, so back to performance. Around 2014, we sort of made our first foray into the SBC2 landscape. We actually released the 7420 model and published numbers. I think these were one of the first numbers we published in this space. Looking back through my history, this is the earliest one I could find anyway. It could be that we had some earlier numbers that I didn't see. And as you can see here, we at that time posted the top number in the charts. And you can see actually down a little lower, an older 7420 with an Halem architecture was also very respectable in this environment. So we were very pleasantly surprised that with an appropriate amount of tweaking to things, that we could be very competitive in this space. And so we, from this point on, pretty much routinely would publish results that put us near the top of the heap for storage, and continue to do so, actually. Our recent numbers in at least the SBC2 and Spec ZFS benchmarks are very, very respectable. All right. Finally, in this sort of historical context of what was happening between 2010 and today, Oracle has moved strongly into cloud. I don't know if you're aware of this, but Oracle now claims to be pretty much a cloud company. Despite, I think, claims early in 2010, I remember Larry saying he didn't know what this cloud thing was and it wasn't going to be important. But Larry is, if nothing, adaptable. And so we started at Oracle with software as a service. This was really an outgrowth of services that Oracle had been providing actually for a long time. Remember those Austin data center slide I showed you earlier. There on that slide was this comment that it was supporting thousands, or actually at least hundreds of customer applications. Oracle has for a long time supported hosting customer database and middleware within data centers for customers. And in fact, that was some of our biggest headaches. That VP who went to Larry and tried to kick us out of the data center was primarily concerned with the customer environment, because that's where she was getting beat up. Every time we went down for a period of time within that environment, that impacted customers, and so there'd have to be these awkward phone calls to the customers saying, yes, I'm sorry, your services went down for N hours while we dealt with whatever issue that had come up. Oracle evolved that into, or maybe just rebranded that perhaps, into software as a service. All right, so software as a service was run primarily on engineered systems, the Exadata system, if anybody of you are familiar with that. It's a piece of hardware specifically designed to run database, but it was also coupled with a need for storage, and that storage was provided by ZFS. So ZFS was deployed quite early in that environment for the storage needs of the SaaS environment. This is still the fastest growing part of Oracle's cloud, as far as I know, is the SaaS, because of course this is what Oracle does best. It's database and middleware, it's fusion. In around 2013, Oracle purchased a company called Nimbula. Nimbula was infrastructure for platform as a service. They deployed that in around 2015, I think early 2015, if I recall correctly. And this is still what what Oracle offers as PaaS in its cloud. It's based off of that Nimbula technology. This is the second fastest growing piece of Oracle's cloud, and probably at some point will overtake SaaS as its premier service. In this environment, this is platform, so what the needs here for storage is primarily LUNs to populate the instances, and so ZFS is the source of all those LUNs in this environment. So OPC really, OPC by the way is Oracle Public Cloud, is firmly on top of ZFS Storage at the moment. So let's, in fact, transition to the present and talk about what it looks like now in the world of Oracle and ZFS. The most current ZFS Storage is the ZS5 series. As you can see, this is, the key to our success has been very large memories. We were sort of the first out there to pump up the size of our memory. From, classic NetApps had 16 gig of memory, 32 gig of memory or something. And we quickly realized that the thing that made ZFS so effective as a storage appliance was its caching ability. And the fact that it could make it's basically a hierarchical storage model, and its ability to make slow disks look blazingly fast. And so with 1.5 terabytes of memory up to 3 terabytes of memory in a system, we could cache a lot of information. And if you had the workloads that were cached, if you could keep that workload in memory and cache, and we did a good job of keeping workloads in memory, that's something that ZFS does very well, then you rarely went to disk. And on top of that, of course, ZFS's pipelined I/O model and transactional model hides, particularly with intent logs and separate intent logs, hides most of the write latency. And so we could publish, that's where we got our numbers. This is where we get our performance. We are one of the few and maybe only storage products on the market today that can support 9 petabytes of storage behind a single cluster. Remember that I told you early that ZFS only had a small foothold in the market in the early days in 2010. Well, today, we are trusted by most of the Fortune 100, top Fortune 100, using cloud, financial services, telco, semiconductor, oil and gas, media entertainment companies across the board. All right, so it's doing very well, as I think Matt mentioned. The sales of this product over its current lifespan have been over $1 billion, and it's maintaining. We have deployed over 25,000 storage appliances and across a broad number of use cases from disk backup to VM. And generally, in these environments, we are supporting multiple of these use cases simultaneously. So it's not even an issue of, yes, we've tuned it this way or that way to address a specific market. Although admittedly, we do have tunings for specific markets. The reality is that it's still a fully functional, very broad spectrum file system and storage appliance supporting a very broad spectrum of workloads. And our biggest customer is the Oracle Cloud. Currently in Oracle Cloud, we have over 28 million users, 2,400 systems are deployed within it, comprising over 1.3 exabytes of storage. And that's growing at a remarkable rate. We're installing over 50 systems a month in the cloud as Oracle Cloud continues to grow. We estimate that within a year, we'll be over 2 exabytes of storage. What? Is that supposed to tell me I'm done in 10 minutes? Are you going to yank me out of here? All right. Life is good, right? Life is pretty good. Life is definitely not bad, but I see warning signs. The warning signs I see is that cloud, and cloud storage in particular, is a race to the bottom. All right? When you deploy storage in cloud, you're trying to sell it at a fraction of the cost of really what it's worth in some places. But the ZFS storage appliance is an enterprise storage appliance. It's designed to supply enterprise needs, and so it's priced above what you normally price cloud storage at. Now, I think we can do some things to address that, and you can reconfigure your storage to deal with that, and I'll talk about that in a little bit. But at the moment, I think Larry is focused on growing his cloud, but he's also aware that he needs to be priced competitively if he wants to make the kind of profits he likes to make. I think that there is a real concern that we could be priced out of that as a storage system if we're not careful. Also, in the Oracle Cloud, ZFS is not exposed, right? It's the technology that sits behind it. But customers never see ZFS. They never use ZFS directly. It's what's providing the LUNs for PaaS. It's providing the access to the files for SaaS environment. But these environments, you don't go in there and address that directly. You don't see that as ZFS storage. You just see it as your storage, and it happens to be supported by ZFS. It's not an option. Well, that's not entirely true. But it's not an option most of the instances deployed in PaaS. We actually do support a Solaris instance where you could put a ZFS instance. And you could, if you through some work, I suppose, put a ZFS instance into your Linux environment. It would take some work on your part. I'm not sure how you go about it exactly. But ZFS is also not being deployed in the object storage service part of the cloud. And this is really where the race to the bottom is most important, because that's where the bulk of your stable storage is going to sit. And right now, that's all white box technology inside of Oracle, which is typical of cloud. And what about enterprise storage? Well, again, we're strong right now in that world. But there is, the fact that Oracle is refocusing its interest into the cloud. And as such, it's going to be potentially, I fear, less interested in selling in the enterprise directly. And the enterprise itself is changing its focus. It's less interested in acquiring more storage for its data centers and more interested in moving to some kind of cloud environment where you have some combination of private and public cloud supporting their infrastructure. And so I fear that market may be shrinking on us. Ultimately, my fear is that ZFS is on a path to becoming a niche technology. All right. And this concerns me because I want to see ZFS everywhere. I think it should be everywhere. It is the best technology out there for storing your data. There's no reason why it shouldn't be out there everywhere. So does ZFS have a future? Well, absolutely. I mean, this set of companies represented here are certainly a part of that future. And Oracle is certainly strong in that space. But I think there are things that could happen and should happen to make sure that ZFS continues to progress and grow and become stronger. So first of all, ZFS and Linux. And before any of you get too excited here, I'm the ghost of Christmas future. This is not what will happen, this is what could happen within Oracle. What I would like to see happen in Oracle is that ZFS becomes a core part of Oracle. Of Linux, not an add-on, bolt-on piece of Linux. All right. And in fact, from the ZFS perspective, I'd like to see us look at Linux as a core supported platform so that every feature and every bug that we develop targeted to Linux, as well as Solaris, but targeted so that Linux is always up to date. All right. It should be a focus, all right? Because if it becomes a focus and it becomes part of core Linux, and ideally the default file system in Linux, then that would be a huge battle. That would be a huge win for us. All right. Now, it could happen, right? What I would like to see happen is that Oracle port its version of ZFS into Oracle Linux. This would be, I think, a very intelligent thing for Oracle to do. And then push that out, ideally, upstream into Linux in general. Will that happen? That's hard to say. Oracle is very protective of its IP, but we've had conversations about it. And I think there is a possibility there. Another place where I think ZFS needs to focus some energy is in the persistent memory space. All right. Intel's recently released their 3D cross-point memory. It's nearly as fast as DRAM, and it's fast enough that you don't have to stall IOs when you're doing IO to it. It's cheaper than DRAM, and has 1,000 times the endurance of NAND. So with that, combined with the growing density, right now the high density is 6 terabytes for 2-socket systems, as is being announced currently, but that's likely to grow. That represents a very intriguing storage platform. This is the model that Intel envisions one access their persistent memories. ZFS fits in nicely there as the file system in the middle right now, but that just means it can exist in that ecosystem. Where I want to see us move is to the right, the PMEM-aware file system, because then we can leverage this technology. All right, we need to be able to access block storage, access PMEM as block storage at the sorts of latencies that are capable there efficiently in ZFS. So we need to optimize our IO path at ultra-low latency. We need to support DAX, direct access to PMEM. That means memory mapping, persistent memory, exposing it to the application, which almost certainly means pre-allocated storage, which raises the question, how do you do checksumming in that world? Can you do checksumming in that world? I'll leave that as an exercise for all you all to figure out. And I think we need to leverage PMEM in the technology of ZFS itself, specifically within the ARC and the ZIL. Persistent persistent L1 ARC caching, I think, is really important. How many minutes am I allowed to go over? And ultra-fast intent logging, I think, are both really interesting applications of persistent memory that can be for direct utilization by ZFS as opposed to exposing it to application layer. And finally, ZFS in the cloud. Everything's moving to the cloud these days. So ZFS needs to be there too. I mean, I've talked about ZFS supporting the Oracle Cloud at the moment, but I've also talked about the fact that it's at risk in that environment. And I also talked about the fact that it's not exposed in that environment. I think we need to get to the point where we are the solution for the cloud. All right. Object storage should be based on ZFS. Right? ZFS is good at supporting cheap drives. I don't know if you remember that. How many of you have seen early versions of ZFS The Last Word that Jeff Bonwick and Bill Moore used to give their dog and pony show around? But there was a slide on there, and I forget under which section. I think it was around the comparison of ZFS to between various configurations of hardware. But there was a tagline at the bottom that said, ZFS loves cheap storage. And we eventually removed that line, at least I did, out of the presentations I gave because we weren't selling cheap storage. But the important part of it was that it was there to say, if your storage is not reliable, ZFS can add that reliability to that storage. You don't need to have enterprise class storage sitting down there for ZFS to be able to utilize it and still be as effective as if it was, because we will discover problems, we will correct those problems. And so ZFS could be and should be deployed in these object environments where you do want to preserve your data, despite what the cloud is actually providing you right now. And I think it could be really interesting to look at how ZFS could be deployed in an object storage environment as part of either the underlying, just storing the data, the raw data itself, and the possibility that we could evolve ZFS into a scale-out implementation. I don't know if there's really a need for that, but I think it's an interesting thing to think about. And also file system services. I'd like to see ZFS deployed, or at least available at the instance level, where instances can and should be using ZFS directly all the time, if nothing else for the extra data services it provides to them. I think it could be deployed as a software-defined storage as a service in the cloud, and should be in every cloud as something you'd want to have there. And potentially it could be part of some type of elastic file services. But again, that requires a fair amount of tweaking of ZFS to make it effective in that environment. I had some ideas there, but we'll see. So in summary, ZFS is proven technology. It's extremely successful in the market today, in both the enterprise and the cloud space. But it needs to keep moving forward, all right? It needs to be the file system for Linux. It needs to be on top of all the new storage technology, like persistent memory. And it needs to become the go-to technology, the go-to storage in the cloud. Thank you. I think I used up all my time, didn't I?
You did. Do you want to take some questions?
If I'll take a few questions, if I can.
We'll give 5 minutes for questions. If there are any.
Wow, excellent. Yes.
Does the ZFS storage operating system, is that a product you can get to?
Yeah.
Or is it do you need to buy the Solaris?
So the ZFS storage appliance.
Not the, I was thinking of the software that runs the ZFS appliance.
The software itself, what we call the firmware in the business, is not sold separately. Yes?
I saw in your feature list something that said file level cloning. Is that essentially like reference links under Linux, or is that something else?
It is like reference links under Linux. That's where we would hook it in in fact, it's the reflink system call is what we use to trigger it. And yes, it's essentially taking a file and creating a new version of the file where we have block pointers all point to the original file.
Right now in Oracle ZFS, correct?
Yes, correct.
Please restate the question.
Oh, sorry. Yeah, they can't hear. Yes. So the question was whether the file level cloning was the reflink in Linux, and the answer was yes, it is. Yes. So the question was, under file services that are provided by the storage appliance, how much is NAS versus SAN, effectively, I think. So that's an interesting question. ZFS, I think, it's fair to say that the storage appliance excels as a NAS server. The combination of ZFS technology and NFS technology, which also came out of Sun Solaris, is very good. And so our ability to serve up NAS from the appliance is stellar. But we're also very effective at serving up block. And so within the cloud environment, when I talked about PaaS and SaaS, in the SaaS environment, it's all essentially file level services. In the PaaS environment, it's all essentially block services. And we've tuned over the years the block, the iSCSI primarily there, service is very effective, very, very fast. So in the markets as a whole, I would say that we probably sell more strongly into NAS, but we also have a pretty good foothold in SAN. The main holdback in the SAN environment, so the main stumbling block in selling, for example, competitively against something like some EMC, for example, is that our failover times are still in the range of 20 seconds, whereas the top tier SAN environments, they want a failover time sub 5 seconds, and we just aren't there yet. Any other questions? Brian?
So, I mean, the feature list you talked about, as you mentioned, many of those were implemented in OpenZFS. You also mentioned you had an acute problem in essentially the entire Fishworks team, not the entire
Yes.
ZFS team.
Yes.
Had an acute problem of not having the people you need to implement those features. Then people in the community implementing those features.
Yep.
It seems that it would have been economically viable to actually participate in the community instead of going your own route, just from a pure dollars and cents perspective.
Yep.
Has that topic been raised?
Yeah, so, and that's an interesting question. I mean, yes, why doesn't Oracle participate more in sort of the open communities and leverage the brain trust there and the resources there? That was the question, effectively. And the answer is that, Oracle is a very, again, I mentioned earlier, very tight with its IP. It's very unwilling to play in that space, as you well know. And I think that despite the potential economic benefits of being more strongly in that community, it culturally has a very difficult time participating there. Now, it's funny, though, because you look at their Linux OL community, and that does participate there. But that's mostly a take. It's not much of a give. And so I think if you could build up a model where it was mostly take, Oracle would bite. But it's that giving part that's hard to get to sell up the chain. So I have had conversations about it, and there has been some interest at various times.
Is there any possibility that any of this will be open source? Because honestly, you say we might be interested in stuff. We're not interested in stuff that's not open source.
Yeah.
Is there any possibility?
There is a possibility. I think I can say that. I can't tell you how strong a possibility there is. And like I said, I've had conversations involving even the lawyers at Oracle around the subject of licensing with ZFS and even Solaris. To date, there's been no motion there. Could there be? Maybe. Things are changing a lot within Oracle these days in this space. So I can't give you a stronger answer on that, I'm afraid, at the moment. But I have hopes. Yes?
Given the importance of cloud, have there been any efforts to make ZFS distributed?
It's a good question. Have there been efforts to make ZFS distributed? Yes. I had a project. I had a kind of a skunkworks project for several years in that space in various forms. So there have been efforts. Is it distributed at the moment? No. All right, I think I better hold this down. Thank you.